Problem sheet 8, question 2. Consider the following project. Draw the activities on nodes diagram and find the critical path. Draw the activities on arrows diagram and find the critical path. Draw a Gantt chart for this project. So let's start with the activities on nodes diagram. Each activity will be a node with arrows indicating prerequisite relationships. So we start with the dummy start node. A, B and C each do not have any prerequisites, so the start node will be their prerequisite. D has A and B as prerequisites. E and F both only have C as a prerequisite. G has A as a prerequisite. H has D, E and F as prerequisites. I has F only as a prerequisite. And finally we have an end node whose prerequisite is all those activities without prerequisites themselves. In this case G, H and I. So this would be the general structure of our activities on nodes diagram. Each node now, instead of being just a label, we need it to be a box which will contain the duration, earliest start time, latest start time and the float, like so. And we can start filling in the duration for each of these in the bottom left hand corner of each of the boxes. With the start and end dummy nodes having duration of 0 each. Now to find the critical path we need to do a forward and a backward pass to find the earliest and latest starting times for each of these activities. The forward pass like so, and now the backward pass to find the latest starting times for each of these activities, such as the project is not delayed. Like so. And finally we can fill in the float for each activity, which would be how much slack or leeway we have for each activity, such as the project is not delayed. That would be the latest starting time minus the earliest starting time for each activity. And so the critical path will be the sequence of activities from start to end node with float of 0. And so our critical path is A, G. B. Draw the activities on arrows diagram to find the critical path. Now the critical path should be exactly the same now, AG, if we do this properly. We're just using a different technique to find it. So in this case, nodes are just points of time and arrows represent activities that take us from one point of time to another. Now I need a dummy activity joining the end of A to the end of B, as activity D has both A and B as a prerequisite. However, G does not have B as a prerequisite, so they can't emanate from the same node. So we need a dummy activity between A and B. Similarly now I need a dummy arrow between the end of F and where D and E meet, as I have activity H which has D, E and F as a prerequisite, but I also have activity I which only has F as a prerequisite, so I need a dummy there. And this would be the activities on arrows diagram. Key points here, we always start at the same node and we always end at the same node. To do a forward and backward pass of this, we'll find the earliest and latest times we can reach each node, which are points in time. So the start node The earliest time we can reach there is 0. The earliest time we can reach here is 1, and so on. And a backward pass. Which completes our forward and backward pass. And we will find our critical path by identifying the set of activities such that the node at the start of the arrow have the same earliest and latest starting times. The node at the end of the arrow have the same earliest and latest starting times. And the starting times at the end of the arrow minus the starting times at the start of the arrow is equal to the duration of that activity. And so our critical path, again, is AG. Finally, C, draw a Gantt chart for this project. Now this is very difficult and probably won't come up in an exam. However, it is important that we can read Gantt charts, and if we can draw Gantt charts, then we can read Gantt charts. On a Gantt chart, the y-axis will be parallel activities and the x-axis will be time. We can start by considering our critical path, AG. We know we can always draw a critical path in series, and therefore the time here must be 1 and the time here must be 13. B and C can be done in parallel. They can both start at the start of the project. B and C, where this is time 3. How about D? D needs both A and B to have been completed. So D can happen after B, as long as we draw our prerequisite arrow between the end of A and the start of D. Now both E and F can happen after C has completed. So let's draw F after C. So it'll take us to time 7. And E can happen directly after C. So we can say E starts here, which will only take us to time 6. But there is a prerequisite between the end of C and the start of E. Now I can occur after F, taking us to time 9. And our only other activity to place in this Gantt chart now is H. Now H must have waited for D, E and F to all finish. So it can only happen after F has finished. I can place it either here or here, it does not matter. And that will take us to time 11. But we need to show that F, E and H all need to finish before H. So we can draw our shade float here between D and H, and a shade float between E and H, and our prerequisite arrows. And that would be the Gantt chart for this project.